In this video, we're going to look at cleaning up messy data. So let's say I want to make a graph, a histogram of height. So I select height, and we'll just go ahead and do frequency is fine right now for our purposes. Now, I look at this and I see, we have some very interesting issues. This is a person's height in centimeters, and we have a couple of outliers here. Somebody who says they are between 650 and 700 centimeters in height, and someone who says they are between 800 and 850 centimeters in height. And we also have some people that are between 0 and 50 centimeters in height, and between 50 and 100 centimeters in height, and between 100 and 150 possibly. Okay, so we've got some very strange heights here. So just to show you that these are definitely strange heights, Yao Ming is 7 feet 6 inches tall, and he's 229 centimeters. So 600 and 800 are totally unrealistic. And these are all high school students. And let's say just in an extreme case we have a high school student who is only 4 feet 6 inches tall. That would be 137 centimeters. So we're going to be pretty skeptical of anything that is less than 130, maybe even 140, or something bigger than 220 or so. So let's go back and take a look at our heights here. So we see that none of the values in these two bars are even plausible. Probably quite a few in this bar are not plausible. There might be a few in here that are not plausible, and these two are definitely way out of line. So basically all of the heights that we are thinking are pretty realistic are in this bar right here. So we have some issues that we have to deal with. So I'm going to go ahead and close this graph here. Oh, that's not what I meant to do. I want to close it. Okay, so I'm going to need to clean up this data. Now the way to go about this is I'm going to go ahead and go to Data and Sort. And I'm going to pick my height data here. And I want to sort it ascending, which means smallest to largest, because I know that it seems like I have two small values than two large values. And I'm going to open these in a new data table. Okay, this is going to think for a minute. Okay, we finished thinking. Okay, so clearly we have a problem here. A person who is not 1.76 centimeters tall. We need to think about what they did wrong. Well, this looks like they put it in meters instead of centimeters. So this is an easy fix. We just have to change the decimal place. Now here we have 5.4 and 5.6. My guess is this person is either 5.4 feet or 5 feet 4 inches, and so they have these in feet and inches. 23.75. Not sure what they did wrong. That might be actually their foot length instead of their height. Maybe they switched them. I'm not sure. I'm not sure what they did here. Now the 51 through 88 here, and probably the 103, and even possibly the 127, 129, but probably the 51 through the 103, they when they were measuring, they had some sort of a tape measure that started over every meter. So these are probably 151, 157. So these just need to have 100 added to them, probably all the way up to 103. Now, a couple that are going to give us a little bit of a problem then are these 127, 129, 130, because we said it's pretty realistic that anybody would be over 220 or under 137. Okay, so 229 is extremely tall, highly unusual, and 137 is extremely short. So when we look at this sorted data, what do we do with these in here? These are too short to be realistic, but if we add 100 to them, they're too tall to be realistic. So I'm not sure what they did. in this group right here. Some of these in this little area right here. So we'll have to kind of make a decision what we want to do about those. Now the rest are in pretty good shape until we get to the very end, and we see here 230 I'm a little skeptical about. We've got a Yao Ming type of a person here, but it's probably okay. We can leave that. But the 650 and the 804. Now, other than a person making a measurement error or putting something in units instead of feet instead of centimeters, so they did a units issue, realize we're dealing with teenagers here, so some of these are probably just stupid answers. Someone didn't want to bother to measure themselves, and their teacher told them to do it, so they just filled in some number, made a wild guess. So, and that might be true of some of those ones in the middle. So, if we're not sure what they did wrong, our only option is to delete it. So we need to either correct or delete these values. Make every effort to see what you think they did wrong and correct it. Now, if it's in feet and inches, you can do a Google and go an inch to centimeter converter, or you can just recognize that if we go to 1 here, 1 inch is equal to 2.54 centimeters. That's kind of a useful conversion to know, so if you want to go back and forth between inches and centimeters. Oops, wrong data table here. So once you've made those corrections, then you can go back. I'm not going to go through and do them all because it takes a pretty long time. But once you've made those corrections, then you can redo your data table, and it will make a whole lot more, redo your graph. It'll make a whole lot more sense.